Hello class, this is the video solution to lab 1.9 through 1.11. You have Jason, he pours himself a glass of iced tea from the refrigerator and then leaves it on the kitchen counter while he answers the phone for a 10-minute conversation. He drinks all the tea. So when I look at this, it says, is the temperature of the tea a function of time? All right, so right away, I always want to kind of think about what's the input and the output. Whatever comes after the words of function of is always your input. So function of time is your input, temperature is your output. And you think about the definition of a function. For each input, there's one output, okay? So if the input's time, for each time, there should only be one output, only one temperature. In that case, that makes sense, right? At the end of 1 minute, the temperature is not going to be 40 degrees and 70 degrees, right? There's only going to be one temperature at the end of 1 minute. At the end of 2 minutes, there's only going to be one temperature, right? The temperature of the tea will not be 39 degrees and 62 degrees, right? It's only going to have one temperature, right? So for each input time, there's only going to be one output temperature. So we could say this is a function. That's the very basic definition of a function, okay? Which quantity should be represented by the independent variable? Remember, independent variable is the input, okay? And I just took the liberty to kind of jot something down here. Again, we were given temperature of the tea is a function of time, right? We said whatever comes after the word function of, that's your f of parentheses. The word after of goes inside the parentheses, right? So we remember the output is always equal to f of the input. So since time is in the parentheses, the output is the input. The temperature is the, the time is the input. The temperature is the output. All right, so the independent variable, the input is going to be the time, and the dependent variable, or the output, would be your temperature, okay? Right, the temperature depends on the amount of time. So it says choose variable names. Okay, well, we'll use capital T for temperature, that's the output, and time will be X, our input. If you use different letters, that's fine, right? Some people use T for time and maybe TP or TM for temperature. Those are all fine, okay? But we use temperature for T, and X is time. So T equals F of X, right? The output equals F of the input, or you can write it the other way, F of X equals T. The order doesn't matter. So interpret, okay, well, if what's in parentheses is the time, if the time is 5 minutes, the temperature would be 50 degrees. Or you could say after 5 minutes, the T is 50 degrees, okay? Write in function notation, okay. After 8 minutes, the temperature was 58 degrees. So 8 minutes is the time. So I put the time in parentheses. So F of 8 equals the output, which would be the 58 degrees, right? Remember, we said that the output was the temperature and the input was the time, and the input goes inside the parentheses, right? The X goes in the parentheses. So if the time is 8, 8 replaces X. The temperature replaces the output, okay? Practical domain, and it says there are many correct answers, okay? Well, think about it. If the tea's in your fridge and you're on a phone for a 10-minute conversation, well, the time is your domain, okay? And again, you were told that it's a 10-minute conversation, so I would say maybe a good domain would be from 0 to 10. If you said, well, it's a 10-minute conversation and it takes 2 minutes to drink the tea, maybe you say 0 to 12 or 0 to 15. Again, there are many correct answers. You just shouldn't write, negative 10 to 10. That wouldn't make any sense, right? You're not going to be on the phone for negative 10 minutes. Or 0 to 100, right? It was a 10-minute conversation. Probably not going to take you 100 minutes to consume the tea. All right, so I think 0 to 10 would be appropriate. And notice we used X because X represented time. Practical range, right? And notice this says practical, right? Practical just means in the context of our problem. All right, so if the temperature in your fridge is, say, 35 degrees, 40 degrees, notice it says there are many correct answers. I keep my fridge at like 36 degrees, so maybe I would say 36 to whatever room temperature is. Maybe the tea will warm up to room temperature. So maybe your house is at 60 degrees or 65 degrees. Again, there are many correct answers. You just wouldn't write 0 to 100, right? Because 0 would be a block of ice, right? If the tea came out at 0 degrees, it would be frozen, right? And 100 degrees, well, the tea will never get hotter than room temperature, right? So if your house is at 70 degrees, the tea is not going to warm up to 100 degrees, right? It will just approach room temperature, okay? So the practical range would be somewhere between, say, 40 and 60 or 35 and 75. There are many correct answers. Part 8, okay. Does this graph pass the vertical line test? Well, if I draw a vertical line, if it intersects the graph more than once, the answer is no. It fails the vertical line test. Here, anytime I draw a vertical line, there's only one intersection, so this passes the vertical line test. Question 9. All right, we have a plumber. The job will cost you $35 for parts and $40 per hour for labor. Use function notation to write the equation that gives the cost of repairs as a function of the number of hours. So again, function of, whatever comes after of is your input. So number of hours would be our input. So the slope would be the $40 per hour. That's our rate. The rate of pay is the 40. The 35 for parts is what's fixed. So your initial cost before labor is $35. So the B in Y equals MX plus B is 35. The M is the 40. And my equation would be, okay, well, function notation, the cost is a function of the number of hours, which in this case would be $40 per hour plus the 35 for parts. If I evaluate f of 3, well, the 3 means the plumber stayed for 3 hours. So you would pay 3 times 40. Oops, it looks like there's a mistake here. This should say 40 times 3. Let me correct that, right? Because we're going to substitute this 3 in for h. So 40 times 3 is 120, and 120 plus 35 should be 155. So I have to correct this. Okay, so I made some corrections here, right? Because it was $40 per hour, right? So 40 times 3 is 120, plus the 35 for parts equals 155. So after 3 hours of labor, the cost will be $155. That's it. I hope that helps. If you have any questions, please let me know. Have a nice day.